Greetings and welcome back to Stellarium Planetarium Software for Astrologers, an instructional video series with your host and celestial navigator, Gemini Brett, the 2023 edition. This is the 12th video in the series, which is quite appropriate because today we are going to make our Stellarium layout look most like an astrology chart wheel. All right, so we need a few key elements. We need the horizontal line, which in any quadrant house system, like Porphyry, Placidus, Campanus, Alcibiades, Coke, on, is the horizon, is the ground beneath our feet. So we have the ground in Stellarium, but what if we take the ground away? Well, we need something to mark that horizon line, right? Charts like Stellarium let us look beneath the ground into places we could never see with our eyes. We also need the quote unquote vertical line, which is the meridian, dividing the eastern sky, which goes up, from the western sky, which goes down. And we need the circumference of the chart wheel, which is the path of the sun, the ecliptic plane. And since our solar system is relatively flat, the place where we will find the planets. Now, in the northern hemisphere, well, all temperate northern hemisphere latitudes like California, we always find the ecliptic in the south. And that's why I have my view here towards the south. In the southern hemisphere, at least for all earthly latitudes south of the Tropic of Capricorn, the ecliptic is found in the north. In the tropics, it's in the south for part of the day and in the north for part of the day, like at the equator, which is neither northern hemisphere or southern hemisphere, and both. The ecliptic is in the north for half of the day and south for half of the day. I'm going to stick with California in this particular video. Our chart wheels were designed to simulate the northern hemisphere astronomical experience. That doesn't mean they don't work in the southern hemisphere, but we're going to stick with the northern hemisphere so we can most kind of accurately model this thing and map this one-to-one in Planetarium software like Stellarium. Okay, so our chart wheels not only let us look beneath the ground, but we can also see the eastern horizon here at the ascendant, which is where the ecliptic intersects the eastern horizon, and the western horizon here at the descendant, which is where the ecliptic intersects the western horizon. We can see them at the same time. Now you would need, bug eyes to do that. It's impossible. But the chart, like astrology, lets us see more of the world than we can see with the human eye alone, at least at any given time. Stellarium does too. So I'm going to zoom out on a Mac laptop, and I have my trackpad settings, kind of my global computer settings, so that a 2-finger pull on the trackpad lets me zoom out, right? That's more of a computer setting than a Stellarium setting. There are zoom in and zoom out keys in Stellarium, which we will get to in a forthcoming video on keyboard shortcuts. Now, I do want to show you one thing that I kind of missed showing you, I believe, when we were talking about the configuration window menu. So let me open that up. One is you have on the main tab where we've been a bunch to save settings, right? You also have save view. So let's say I want to save this view where we are here. I mean, I'm quite bug-eyed. I'm facing south because in the northern hemisphere, that's where we will find the planets. And I'm kind of looking east and west and even further simultaneously. Okay, so I'm going to save that setting. So configuration window, save view. Now, if I was to quit Stellarium and open it back up, this is the view that I would have. But the button that I think I failed to mention when we were going through these menus in an earlier video is here at the Tools submenu, and it's this tick right here, auto direction at zoom out. Click if you click that, and I suggest you do, then the zoom out button, which is the backslash button beneath the delete button, will do this. Let me zoom in on Arcturus. Actually, let me show you what it is without that box clicked first. So I'm going to click on Arcturus here, hit the space bar to center Arcturus, trackpad, zoom way in, okay? Arcturus. Now I'm going to hit that backslash button. And I kind of zoom way out to like, I don't know, I guess my normal field of view, which I have set here at 181. All right, well, let me go back to my saved view. And look, I could quit Stellarium and open Stellarium again to do so, but I'm not going to do that. Instead, I'm going to go in that configuration window. I'm going to hit auto direction at zoom out, and then watch what happens when I hit the backslash button. That's my save view. I realized I hit Q and took the compass directions away because Q is the keyboard shortcut for that. All right, so now like if I'm centered in on Altair and zoomed way in there, when I hit the backslash button, I'm back to my saved view. So I very highly recommend that auto direction at zoom out. It's my good friend. I'm going to save settings to make sure that that is saved when I quit Stellarium and come back in. Okay, so in our last video, we were in the sky and viewing options, and we went through sky and solar system objects, so basically stars and planets. Don't do much. I don't personally do much with deep sky objects, so I just kind of rushed through that. Today, we're going to finish this menu with markings, landscape, sky culture. We're not going to hit surveys because it crashes my computer. I don't know how it does for yours. My desktop upstairs, I think, can handle it, but it's not something I personally use anyway. And then in future videos, we'll get to keyboard shortcuts and then also to this astronomical calculations window and maybe some more advanced things past that. All right, so markings is, I think, one of the most important video or menus in Stellarium. So you can see just all of these options. Remember, anytime we see color squares, that means we can change the color of whatever we're talking about. One thing I see that's already checked here, well, there's a couple things. One is the celestial sphere. And I guess when I unclick that, everything involved goes away. I noticed, however, well, first of all, nothing's clicked, so we can't test that, except cardinal points. And when I did take the celestial sphere away, the cardinal points are still there, like east. So apparently they stay. Of course, they're more about the ground than the celestial sphere anyway. But notice here next to cardinal points, as long as we're looking there, there's an option for 8 versus 16. So 8 is, I assume, going to give us 8 directions, like the cardinal directions, northeast, south, and west, but then also the cross-quarter directions in between, like southeast and southwest, which you see on your screen. If we go to 16, I'm guessing we will see southeast, southeast, and south-southeast, and south-southwest, and west-southwest. Let's test that. Here's 16. There you go. And it looks like we could do 16, but not 8. Interesting. That's how you get 4. That's odd math, Stellarium, right? So when I click 8 and unclick 16, I get 8 cardinal directions or compass headings. When I click 8 and 16, I get 16. But when I click only 16, I get 4. When I first started with Stellarium years ago, you could only get 4. So it's pretty cool that we can take that to 8 or 16 now. I think 8, for my purposes, is the most beneficial. So I'm going to click the 8 and unclick the 16, which seemed to be the default setting once we turned the compass ticks on. And you'll remember there is this compass rose down here. At the bottom of the screen, you can see in brackets keyboard shortcut Q to turn that on and off. All right. So let's just start from the top and we'll go all the way through all of these columns. Equatorial grid J2000. What? Now, first of all, you'll remember we have an equatorial grid icon down here in the bottom menu bar, right? And this is just the equatorial grid. It's a grid based on equatorial coordinates, which are right ascension, and declinations, and angular measurement or hour-based measurement along the celestial equator, and that's right ascension, and declination north or south of the celestial equator. So you'll see these two options, and check out how when I clicked the grid down below, the one that comes in here is equatorial grid of date. You'll see another option. Let's click them both. They're pretty much the same, but slightly off. I don't know if you, I mean, maybe if we cycle back and forth, you'll see that shift more. Yeah. What is equatorial grid J2000? Okay, so you'll see this J2000 all over the place, okay? J2000 is January 1st, 2000 at 12 p.m. Universal Time. And it's a convention that astronomers use just for like a fixed moment in time to, for a fixed moment in time in our modern era. That's as far as I can go with that. I am much more interested in the image of the date, right? Like in astrology, we're usually looking at specific dates and times. I could set this to January 1st, 2000 and play there, but I have it set for February 21st, 2023, which is today, Mars's day. And I have this set for 12 p.m. here in El Sobrante, California. So you know what, one thing maybe I'll do even before we continue playing with this F4 menu is to set the clock here to the same time. I notice the clock is ticking, so I'm going to click the keyboard shortcut 7 to pause time, which I could do with the pause button down there too. And then I'm just going to type in 12:00. Okay. So you can see by the illuminated grass that it is daytime, but Stellarium, like our charts, let me take the atmosphere away so we can see the stars and planets, the wandering stars, even by day. Okay, so back to the sky and viewing options window. But even here, let me just show you that south, which is where all planets culminate at the Meridian Midheaven here in northern hemisphere, temperate latitudes like California. Look at how Sun and Saturn are there right now. That means we're going to find them at the midheaven of the chart, as you can see here. That's quite true. All right. So sky and viewing options. Now we have the equatorial grid, and you know what that is. Fixed equatorial grid. Oh, that is wonderful. Well, let me just test that real quick because I'm assuming that that's gonna like stay put and I could have the planets traveling through it. Oh my gosh. Wish I had that one for class 2 weeks ago. Like, this is a really wonderful way to display the idea of planets moving through fixed houses or divisions of the local sky. This is a new thing to Stellarium from to my experience, and I haven't used this version of Stellarium yet. It's not on my computer upstairs. There's a reason I'll get to today that I've been hesitant to update, but I might have to go there because this idea of a fixed equatorial plane is huge for me. You'll see here that what they're doing is they're using a convention where 0 hours is due south. I'm interested in just seeing that if I go to the southern hemisphere, like down here, does that change? It looks like no. I want to look north. And north is also 0 hours. Oh, interesting. I'm trying to make sense of how our north and south both 0 hours or 24 hours. West here is 6 hours. So wouldn't that make south 12 hours? Shift S will snap me to south, by the way. Yeah, and I guess so. I guess this is like the 12-hour line down here, and it's the 0 hour line up above. So I was actually just incorrect. Let me go back to my default location. When I assume that south is 0 hours, no, it is. It just has something to do with where the equatorial poles, or which are the celestial poles, as we'll get to, are from your local point of view. And I'm sorry if that all is a terribly confusing or whatnot. Let's get back to the menu. I'm a huge fan of this grid. As I said before, I'd never seen it before in Stellarium, or perhaps just wasn't like interested in that button before when I've looked. So I could change the color of it by clicking here. I'm going to leave these, well, most of these today, I think. Okay, so Ecliptic Grid, this is a huge deal. Now, we've already found our way to it. So let me hit Ecliptic Grid of date. We had found our way to it because sometime along the way, well, I'll tell you where it was in the configuration window in plugins, I believe we added, well, I don't know where it was, but we added an ecliptic grid at startup. I'm not sure where that was, but we had already done it because here it is, right? This ecliptic grid down here. And that, as you can see, when I push that new menu option that we've added, it ticked ecliptic grid of date. You can also use an ecliptic grid of January 1st, 2000 if you prefer to be stuck in time. You know, there's one way of just kind of looking at the difference of these two will help you understand something about precession of the equinoxes. But we're going to stick with the ecliptic grid of the date. And this is celestial longitude, angular measurement along the ecliptic plane. I can tell that this of the lines is the ecliptic because the planets are there, especially the sun, which by definition is tied to the ecliptic plane. The planets are not, as we saw last time. They all have their own orbital paths, right? But I can also tell that that is the ecliptic of these many curves because it says 0 degrees, where this plus 10 would be 10 degrees of northern latitude, 2030, or this minus 10 would be 10 degrees of southern latitude. Now this 330 degrees I'm circling on the screen is 0 degrees tropical Pisces, because if you'll remember, celestial longitude is measured from 0 degrees tropical Aries. That's the 0 point. So this would be 15 Aries, tropical Aries. 30 would be 0 tropical Taurus. 45, 15 tropical Taurus. And when we go the other way from the 0 Aries point, 345 would be 15 degrees tropical Pisces. 330, 0 tropical Pisces. 315, 15 tropical Aquarius. 300, 60 degrees from 0 in that other opposite direction. 60 degrees a sextile in astrology. What is sextile? 0 Aries, quote unquote backwards, and the answer is 0 Aquarius. Okay, this is 0 Capricorn, etc. So when I see Mercury here at this 315 line, I can see that Mercury's about 15 degrees tropical Aquarius. And let's find Mercury there, 15 degrees and 10 minutes tropical Aquarius. Of course, I could click on Mercury and then read Mercury's ecliptic longitude, which we set up in our configuration tool video, right? Selecting which information we wanted displayed. All right, so that's the ecliptic grid. I'm going to take that away for now. The azimuthal grid we've discussed before, since it's also one of our bottom menu options, and that's a default bottom menu option. That gives me local altitude, right? Angular height or altitude above or below the ground. And then azimuth, which is like compass heading. Okay. There's no option to do that of J2000 because it's a local thing. J2000 is a moment in time, but not for a particular place on Earth. The galactic grid, you will find that this one is centered around the Milky Way. You see that 0 degrees on the Milky Way, right? So we can measure south or north of the Milky Way, and we could also measure along the Milky Way. I'm interested in learning where zero is, maybe at the galactic center. It's kind of hard to find. Well, here's zero, the very lower right of the screen I'm circling. So that's here. And yeah, that's right at the galactic center. So they're measuring galactic coordinates along the Milky Way from the galactic center and then north and south of the Milky Way. It's not something I use often personally, though I will use the galactic plane. We're going to see an option to bring that in shortly. I'm going to unclick Galactic Grid. Super Galactic Grid, it's like beyond my scope, right? So our galaxy is involved in a kind of greater cluster with many galaxies. I think that's what the Super Galactic Grid is about. It's not something I use. I'm unclicking that box. The equinoxes, these are wonderful. And I love that that Stellarium uses, when I click equinoxes of date, I'm going to choose, and solstices of date. You're going to see a couple things. Let me hit P, is this keyboard shortcut to take the planets away, so you can more easily see. We have this Aries point here with the Aries glyph, or this Capricorn point here with the Capricorn glyph. What are those? Well, that's going to be much easier to see. I mean, we could bring in an equatorial and an ecliptic grid to show that, but that's way too much. It's going to be a lot easier to see when we show only the ecliptic curve and the equator curve, which is coming now. Those are like the most important bits. Okay, so we're there. Fixed equator, wow. So that's like that fixed equatorial grid. I can just put a fixed equator in the sky. I want you to notice, and these are new to, like, I don't know, the last few updates of Stellarium from my point of view. They used to only have one box here, and now they have these 3 rows. I don't think they label them anywhere, so you can just sort it out through trial and error. One brings, obviously, the plane, okay? The next brings this tick marks. Did you see they just showed up? They're super dim here, but like, let me just circle this line that's close to Altair. See that little tick mark? Watch when I unclick that box, see how that went away. It'll be more obvious when I click the next box because it adds measurements to it. Now, this is like, I stumbled my way into hour angle a few trips ago. I forgot which menu that was in, but you can see here that they label this fixed equator hour angle. Let me put the ground back beneath our feet. Well, 0 hours is linked to south because in the northern hemisphere, at least, temperate climates of the northern hemisphere, in other words, north of the Tropic of Cancer, the sun souths at midday. And the old astronomical convention was to measure days from midday to midday, because if you're working with the sundial, it's quite easy to see. It's the shortest shadow of the day because the sun is highest above the ground for that particular day, halfway in time between sunrise and sunset. And since the sun souths, or in the southern hemisphere, the sun norths, or in the tropics, either way, but regardless, unless the sun is directly overhead, which can only happen in the tropics, and it happens 2 days each year in the tropics, regardless, your midday shadow, and I'm not talking about clock noon, I'm talking about true noon, which these days we're calling local apparent solar noon. It's the sun at the meridian, either due north or due south, depending on Earth, where on Earth you are and when. The shadow at midday is always on the meridian line. It's always due north, due south, okay? So it's a very easy and accurate time to tell if you're working with a stick in the ground or any other sundial or standing straight as the trees teach us to, okay? So it makes sense that you would measure that kind of south here in California as 0 hour angles. And this is something that would be used for navigation, for example, but really just also telling time with where the sun is in your local sky. Speaking of, we were gonna have this. Oh, the planets went away. Right, this is very close to midday. Now you can see the sun and the planets are not on that curve, that equatorial curve, or in this case, let me open the sky view options window again. That was this fixed equator. I'm going to unclick those boxes and go to the equator of date, which I think I skipped. Now, first of all, let me just put them both up. You know, it looks like the basically I could just cycle back and forth from one to the other. It looks like the fixed equator color overrides the equator, maybe. I don't know, but they're the same place in the sky. Okay, it's just one, the fixed equator is measuring these hour angles, so they're going to call south. Oh, interesting. I just want to show you this. Like when I click this tick, it doesn't matter unless this one is also ticked. Okay, like I have to get the little divisions on here for that to click. All right, so let's do that with the equator. So that the fixed equator has 0 hours kind of at the noon point, true noon point, or the meridian, which we'll put on soon enough. The equator of date is going to have 0 with 0 tropical Aries here, okay? And then as you can see, they measure in 24 hours from that point, okay? From that point, moving from the west to the east to 2 hours, 4 hours would be next. Let me drag this up so you can see line thickness here. So this applies universally. Be nice if we could change one and not the other. I think the default setting is 1, which looks like this. You can go up to 5. You can obviously see that getting thicker. I like 3. Partitions. Oh, interesting. Well, what happens if we increase that? Do you see how these ticks come in? Right? I went all the way up to the maximum 5. Here's 1. I guess, are there more coming in? Or I think they're just getting thicker. They're getting easier to see. I think I'll leave those both at 3. Right, I can unclick that, and as it was with the fixed equator, we see that those tick marks or hash marks have to be clicked for the display, like 20 hours, 22 hours, etc., to show up. Okay, so when I compare these things, like when I see like 22 hours, that's right ascension, an angular measurement along the celestial equator, which is this blue being that you see in the sky now, and compare that to the fixed equator. Yeah, I mean, now it's like 22 hours is at the 0 hours of hour angle, which basically means, you know, the degrees of the equator that are at 22 hours. And that's very close, by the way, to like 0 Pisces. That's currently at the midheaven. Well, you see that's pretty much true, right? Here's the sun culminating. Right ascension, which is measured along the equator, and celestial longitude or zodiac degree, which is measured along the ecliptic, are not 1 to 1. Like I can't just convert 22 hours to 0 Pisces, but it's close. All right, let's get to the ecliptic here. Hooray. Like the ecliptic should be, if you're using Stellarium as an astrologer, it should be on your screen at all times. All right. So now that it's up, I'm going to go over here and I'm going to go to the main and save settings. There's a few more things I want on there all the time. I mean, I usually take these 0, like the equinox points here indicated, though it's certainly not in the Aries constellation. In our day and age, due to precession of the equinoxes, the Aries equinox, or 0 degrees tropical Aries, is in the Fishes constellation. And that changes over the great cycle of about 26,000 years in our day and age. And it's a big deal, and not enough folks know or focus on this. The solstice is aligned to the galactic core, or the Galactic Cross. What is the Galactic Cross, you ask? Great question. Well, I noticed that our next option in the sky settings here is horizon. I want that ticked, so when I take the ground out from beneath my feet, I still have the horizon line like a chart has, okay? But the next one is this galactic equator. Okay, so we saw the galactic grid before, and here's the galactic equator, which is just the Milky Way, basically. It is this cross of the Milky Way and the ecliptic, which is one of the two galactic crosses. There's one on the other side of the sky. And in our day and age, the solstice, which is Earth's rotational axis, sadly, folks seem to not know that, but it's directed towards this galactic cross, very close to galactic center. Now, I will say I am used to, and I'm going to update it now, I like my galactic equator to kind of be electric blue, something like that. All right, and I use a keyboard shortcut. In my work, that's a very important truth. It's something I teach often in the sacred astronomy of astrology of our day and age, that the plane of our neighborhood, if you will, our solar system, the ecliptic, in the plane of our city, okay, the galaxy, the Milky Way, intersect currently where Earth's southern pole is leaning. That's a once in 26,000 year phenomena, and it's a big deal, okay? So I don't usually leave the galactic equator on my screen. I have a keyboard shortcut that will turn that on and off. We'll get to that later. I like to use X for kind of X marks the spot here. But right now I'm just gonna turn that off. Now with all of these things, and maybe most interestingly with the ecliptic, we can turn on divisions, and then we can turn on label, display, whatever, right? So here you see 0 degrees, that 30 is 0 degrees tropical Taurus. This 330 is 0 degrees tropical Pisces. So you can see Saturn is very close and the sun is just beyond. So here we have the sun at a few degrees tropical Pisces, Saturn almost to tropical Pisces, moving from Aquarius that way. 300, 0 degrees tropical Aquarius, Mercury right in between the 300 to 330. If I zoom in, maybe I'll even get 315 on this screen. No, I don't. They only do 30-degree labels. Be nice if those were labeled Capricorn, Aquarius, Pisces, Aries. I have the Capricorn in the Aries glyphs, which I love that Stellarium uses those glyphs, right? Like it's showing us tropical zodiac coordinates. I wish that we could also show Aquarius and Pisces, and I don't know, maybe I'm working with a very talented computer programmer to create an astrology plugin for Stellarium. At some point, I will be asking for some crowdfunding from the astrological community so we can add signs and decans and terms and bounds and houses and different zodiacs and all sorts of things, cyanotic cycle information, more and more. If you're interested in supporting that project, I ask that you please sign up for my mailing list, which you can do at GeminiBrett.com. All right, GeminiBrett.com. All right. You can find all sorts of goodies at GeminiBrett.com, including on the courses page, my Sacred Astronomy for Astrologers course. All right, where were we? So adding these ticks can be quite cool if you want to be able to kind of easily see where the planets are in the tropical zodiac, because again and again and again, I love to remind you that celestial longitude is measured from 0 Aries. Well, so is right ascension, 0 tropical Aries. What is right ascension? Remember, that's measured along the equator. And here's the key to tropical astronomy in the tropical zodiac. 0 degrees tropical Aries is the place where the ecliptic crosses the equator from the south to the north. The equator is the plane of our rotation. The celestial equator is Earth's equator, the plane of our planet's rotation projected into space. So it's the plane of our day, right? We spin in a day. The ecliptic is the plane of the year, Earth's orbital path about the sun. From our point of view, sun's orbital path about us. And since the solar system is relatively flat, the place where the planets travel, though of course they each have their own course. I wonder whose this one is that just showed up. What? Anyway, so zero Aries is simply about the interface. Zero tropical Aries in the tropical zodiac at large, it's simply about the interface of the planes of day, equator, and year, ecliptic. I think they're helpful to keep them both on there. But as far as having the Planetarium software look like the chart, we don't see the equator on the chart. We see the ecliptic, which is the circumference. We have the horizon now, even when the ground is taken away. I'm going to actually remove the equator for now. And then we need to add one more thing, which is the meridian down here. But I said we'd go one at a time, so let's continue. We have the galactic equator, and of course we could add divisions there and labels there. Super galactic equator, we could do the same thing, right? So we have these grids, and then we have just the equator, the ecliptic being, you know, the quote unquote equator, or the center of the sphere of ecliptic coordinates, which is celestial longitude or zodiac degree, and latitude, distance north or south of the zodiac plane. OC longitude. I don't know what that is. Projected solar equator. Projected solar. I also do not know what that is. I look forward to learning what that one is. I'm close, but not quite there. I mean, it's a tip of my tongue, but I don't want to say it because I might be very wrong. Okay, the meridian. Yes. Having the ecliptic, the horizon, and the meridian boxes ticked will get your stellarium, even when the ground is taken away, to look like an astrology chart. You might say, wait a second, why are these things all different sizes? Well, look at, these are different sizes. The quadrants, the distance between the descendant and the midheaven, which is where the ecliptic intersects the meridian, or the north-south great circle above the ground, is of a distant ecliptic arc than the distance between that meridian midheaven and the ascendant. And the reason why, and this is too much to get into today, is that contrary to popular, false, rather ignorant teaching, the ascendant is only due east twice a day. In fact, when Gemini rises, which is happening here, tropical Gemini rises rather north of east. Tropical Sagittarius sets rather south of west. The descendant, where the ecliptic intersects the western horizon, will always be exactly opposite the ascendant, where the ecliptic intersects the eastern horizon. But unless zero Aries or zero Libra are rising and setting the equinox points, then the ascendant is either north of east, which is true when Aries, Taurus, Gemini, Cancer, Leo, and Virgo rise, or south of east, which is true when Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces rise. That's all tropical zodiac statement, friends. This is the zodiac of the Earth, okay? And what our chart wheels do, if we elect in astrology softwares like this Astro Gold software to draw the wheels with proportional houses, what they do is they align our shoulders to what the tradition called the rudder. That's the ascendant direction, because the ascendant descendant axis rudders back and forth against the cardinal directions east and west every day. If we turn our shoulders to east and west, we're facing the cardinal direction south, which is where we find the meridian midheaven always in the northern hemisphere. But if we align our shoulders to the actual cardinal, or not cardinal, but true directions of the ascendant descendant axis in any moment in time, then our heart is facing the middle place of the ecliptic curve above the horizon, which is always the highest point of the ecliptic in any moment's time. That's inaccurately taught to be what the midheaven is, and I'm teaching more astronomy here than I need to in a Stellarium for Astrologers video, but it's an important thing to know, okay? So you can see here the fourth quadrant. In this particular case, since the descendant is south of east, which is closer to south, sorry, the descendant is south of west, which is closer to south than north of east, where the ascendant in this moment of time currently is. The fourth quadrant here, the 12th, 11th, and 10th houses, is much larger than the third quadrant here, the 9th, 8th, and 7th houses, right? And you can see that in the chart wheel, and you can see it in Stellarium here. It's very helpful. Now, it might look like the quadrants below the ground, which are the first quadrant and the third quadrant, are just giant in Stellarium. That's not what's up. They're behind us. Okay, so look what happens when I turn around and face the opposite direction. The first through sixth houses of a quadrant chart are always beneath the ground. Let me do this. Okay, so we can't see them. They're also like, if we're facing the midheaven, let me just hit my zoom to saved settings button, the backslash button. If we're facing the midheaven or facing the top of the ecliptic curve, which is called the nonagesimal because it's always 90 degrees away from here. In other words, in this moment, it's 1928 Pisces, okay? Then the horizons beneath the ground are behind us, all right? So we're standing inside of this circle, and we lose that kind of knowledge or vision on like a flat screen chart like this. Stellarium actually does a better job of showing that through this in what looks to be a distortion, but again, it's not a distortion. We just have to turn around. We'll see those quadrants are the same size, or that hemisphere, if you will, beneath the ground of the ecliptic, the same size as here. All right, I'm gonna face due south again. That's the Meridian Midheaven always. That is what's culminating. It's halfway in this moment, it's halfway in time between Saturn rise and Saturn set. Okay, when the sun gets to the meridian, which is the local north-south great circle dividing the eastern sky, which ascends, even that below the ground, from the western sky, which descends, even that below the ground, okay? The great wheel. The meridian is where everything culminates or reaches its highest height for the day. That does not mean in any given moment of time that it's the highest point of the ecliptic. Just consider what happens when the sun's in Aries versus the sun in Pisces, where it is now in the northern hemisphere. Aries is going to be longer days for the sun's travel, right? Why? Because the sun literally is higher in the sky. Aries culminates at a higher altitude than Pisces does. That's enough of that for now. So, you know, I might save this view if I was looking at one particular moment in time. But since I'm going to be looking at all moments, my view in the northern hemisphere here is to face due south, because that's going to give me at least the Meridian Midheaven. Let me just move this through time here. And you're going to see that midheaven climbing. You're going to see the midheaven equal the nonagesimal here when the ascendant is due east, which happens again only when the equinox points like 0 Libra, the other place where the equator and the ecliptic cross, okay, when 0 Libra or 0 Aries rise, then the nonagesimal, the highest point of the ecliptic plane, square to there, is at the midheaven where the ecliptic intersects the meridian above ground, but only then. After this point, 0 Libra, watch our ascendant's going to move into southern signs. Okay, like this is a Scorpio rising ascendant here, tropical Scorpio. Right here, this is 15 degrees tropical Scorpio, Zubin el Janubi. Okay, now you're going to see a fourth quadrant that's smaller than the third quadrant. Let's go to that time, which is midnight. There's that near 15 degrees tropical Scorpio rising, Leo midheaven here. And as you can see, the third quadrant, okay, the fourth quadrant, sorry, 12, 11, 10 houses is smaller in arc than the third quadrant house of the or quadrant of ninth, eighth, and seventh houses. My language needs to wake up. This is going to be like at its extreme when solstice points rise. Okay, so here's like 4 a.m. We've got Capricorn rising. Let's go there. Which is the point, you know, we're past there now. Let's go to, I don't know, 3:30. So it's pretty close to 0 Capricorn rising. Okay, and now the fourth quadrant here is much smaller than the third quadrant because the ascendant, well south of east, most south of east, 0 Capricorn rises in that way, is closer to the Meridian Midheaven due south, much closer to the Meridian Midheaven than the descendant, which is way north of west is. Okay, let's show that extreme here. I'll go back to 3:30 a.m. on this particular calendar day, right? So you see that like smaller fourth quadrant than the third quadrant, okay? So again, if I want to look at this through time, like let me just move through time here. I need to focus in on the Meridian Midheaven. Whoa. Oh, I saved a different view. What the heck happened there? Hold on a second. There. Okay. And I can see the midheaven changing in altitude. The midheaven, Meridian Midheaven being where the ecliptic intersects the meridian above ground, okay? And I can see the rudder, I can see the ascendant moving south, let's speed it up, and north across the cardinal directions, okay? So Stellarium can show me so much. All right, let's go back to that chart we had up before, which was 12 p.m. on February 21st. Okay, stop time. There we are. All right, cool. So let's finish our trip through the sky and viewing options menu. I'm going to take the equator away again for now. What's altitude? I mean, interesting. I don't really understand how that's going to be different than meridian. Like when I add angular divisions to the meridian, unclick that altitude box, I'm getting 0 at the ground, and 30, 60, 90, of course, is the zenith right above my head, right? Just unclick all of that and then do altitude instead. How is it going to be any different? It's not. I mean, I know this in the meridian, the 90. I guess it stops at the zenith instead of going back behind me. Or I see, no matter which way I face, I'm going to have that negative 90 at the nadir to the positive 90 at the zenith above my head. So that's kind of cool. I mean, I get that also from the azimuthal grid, right? But if I don't want that overwhelming grid and I want to be able to see altitude in other places, like, yeah, I'm seeing more and more use for this. So for example, if I'm kind of looking at the altitude of Mercury here, which is just above 30, as you can see, well, I could see maybe in the sky, Mercury seems to be co-altitude with, something to the left or right. Okay. I'm not sure. The co-altitude might be if something's at 30, the co-altitude is 60. You should be careful with that term, but I mean at the same altitude when I said that. So that thing's cool. All right. Thank you, Stellarium, again for educating me. It happens every time when I play with this software. Okay, I'm going to take altitude off and turn the meridian back on. Colors. Equinoctial colors. Solstitial color. Okay, I'm just kind of uncultured. I don't know how to pronounce that. It sure looks French. And I also don't know what that is. It's something I'd like to learn. You can see them crossing here. You can see that they're moving through the solstice point, the solstice one, and through the equinox point here. But I don't know what it is, and I'm not going to use it. Oh, precessional circles. Wonderful. So Earth's axis, which always points due north and due south, it defines the terrestrial cardinal directions, okay? Where it points in space changes over about a 26,000 year cycle called axial precession, the third motion of Earth. In our day and age, the North Pole, the North Celestial Pole is here. Let me go back to sky and viewing options. And we're going to skip prime vertical. I'll get back to that next, but look at celestial poles of date. Okay, so let me click that. And now you're going to see NCP, North Celestial Pole, here at Polaris, Pole Star, North Star. That's only in our day and age. That changes through time. In our day and age, you will see that the equatorial grid is centered around Polaris. It's always centered about the north and south celestial poles, where our rotational axis points in the heavens, north and south of Earth, right? We're spinning about that axis. So that's the axis of an equatorial grid, the equator being the plane of that rotational motion, right? This shows me where the, in the precessional cycle, other North Star candidates. Okay, so the first motion of Earth, primary motion, is our daily rotation. The secondary motion is our annual orbit or revolution about the sun. Our third motion is this axial precession, which takes about, well, the old canonical number is 25,920 years. Is that even right? 72 degrees, or sorry, 72 years per degree times 360 degrees, 25,920 years. Astronomers today use a number that's actually closer to what appears to be a Mayan number. It's like 25,700 something years. Anyway, one thing I'm wondering is, can we add tick marks to that? It looks like yes. And oh, amazing. I believe this is new in Stellarium and I'm loving it. I hate that I'm going to lose a couple really important things in my work that I'll show you still today. But this is an amazing new advent in Stellarium. See that 0? That means at like 0, BC AD, that's where the North Celestial Pole was at that time. Let's confirm that. Let's just go back in time to, I'll just set this to 1. And now you see the North Celestial Pole there at 0. Okay. Go back to 2023, and here we are around the 2000 point. If we go to 4023, now you're going to see the North Celestial Pole there at 4000. Okay, this is a cycle. So what was, oops, that's 42023, 40,000 years from now. Where is it? Here at negative 1000. What? How is negative 1000 the same as 40,000? Well, it's a 26,000 year cycle. So 40,000 years from now is what? 26,000 plus 14,000. that plus 14,000 is half of a cycle. Well, it's half of a cycle of 13,000 plus 1,000. Anyway, I'm going way too far, but play with the math. What was negative 12,000 here near Vega when our North Celestial Pole was close to Vega? That will be the same as 14,000 years from now. Okay, because it's 26,000. So here's minus 13,000, like that's the other side of the cycle. But that's the other side of the cycle from 0, right? We're already 2,000 years past that. So the other side of the cycle from where we are now is 2,000 minus 13,000, which is this minus 11,000. Or we can add 13,000. So when we get to 15,000 years from 0, okay, we're going to have the North Celestial Pole on the opposite side over here where it says negative 11,000. I could also call that positive. Let's check this math. 15,000. See that? Okay. Anyway, that's a little bit too much and not too elegantly presented, dare I say. But that's a really wonderful option here now in Stellarium to be able to put years to the precessional circles. Love it. Okay, I skipped the prime vertical here. Let me snap back to my view. In the prime vertical, no, I thought it was V, but it's not. I changed that keyboard shortcut to V. I see V brings in constellational labels. That's the default V, I guess. The prime vertical is perpendicular to the prime meridian. So, or sorry, the meridian, right? So the meridian is a north-south local great circle. It goes through the zenith directly above our heads. Let's show that in the azimuthal grid. Okay, it goes through the nadir down beneath our feet, which is down here, and it goes through the cardinal directions north and south on the horizons. The prime vertical goes directly above our head through the zenith, directly beneath our feet through the nadir, and it goes through the east and west directions on the horizon. It's necessary for some mathematics of particular house systems of dividing the sky. Like Campanus house systems rely upon divisions of the prime vertical, for example. It's also necessary if you want to find the vertex of the chart. Okay, so the vertex is always due west. It's where the ecliptic, the heart of the zodiac, crosses the prime vertical. So it's either beneath the horizon due west, as it is in this case, in about 10 degrees tropical Scorpio. Let me add the vertex to this chart wheel. There you go, 11 Scorpio. And I could tell because it's very close here to Zubin el-Janubi, which is 15 degrees tropical Scorpio. Okay, I could have zoomed it and maybe gotten more accurate, but I'm within a degree. I feel pretty good about that. All right. When the descendant is north of west over here, then the ecliptic will intersect the prime vertical above the ground. All right, so a little bit about the vertex. The anti-vertex, which is where the ecliptic intersects the prime vertical in the east, and so it's always due east, is always exactly opposite the vertex. So that's currently 11 degrees tropical Taurus. You can see it's between the north node of the moon and Uranus at this time. Here's Uranus. Let's get the north node of the moon on the screen. Just bringing the moon's orbit. Okay. So Uranus is over here. Here's the north node, and our ecliptic intersection with the prime vertical in the east is on that side of the screen. Okay. All right, snapping back to my regular point of view, taking the orbits away. I'm going to take the prime vertical out of here. It's not used too much in astrology. Again, it is used with finding the vertex and the anti-vertex. Some astrologers work very intentionally with the vertex, especially as kind of like an alternative descendant. And I've heard that it often shows up in synastry with folks, since it's like West is kind of descendant oriented, the place of the seventh house and relationship. Okay. And it also, as I said before, the prime vertical is necessary for some house system divisions. Okay, so we saw the celestial poles already. You know, they're nice to have in there when I'm like teaching primary motion. I use a keyboard shortcut for that, which we will set up coming forward. We saw or no, we didn't see the circumpolar circles. Okay, so those, oh, okay, I see. This is basically showing me here a circle of stars that will never rise. Let me move this through time. Okay, so Canopus here in California never rises. I'll never forget when I met that star in Hawaii. You know, it's like, woke up in the middle of the night. It was like, serious? Such a bright star. And I was like, no. And I had to walk out there and I got to meet Canopus. I made a video, I think it's probably 5 or 6 in this series, where I kind of moved around different places on Earth to help you see why the sky changes from one place to another. So these circles, this is really helpful for my teaching too. Stellarium has added a lot since I've last updated. These are cool. So people call these, like, it's anything in this particular circle, and this is going to be based upon a particular latitude on Earth, like I'm 38 degrees north of the equator. But all the stars in this circle, and I guess on this circle, let me stop time, will never rise. They're called never rise stars. And on the other side of the sky, these stars in this circle, like all of Draco, or almost, it looks like this star, Altanin, is outside of the circle. But anything in that circle, let's just face due north. So shift N for that, and LLL to move through time. None of the stars in that circle will ever set in this local place. So that's like a very convenient tool for me. I'm hitting my backslash to get back to my normal point of view. Function F4 to open the sky and viewing window. I'm going to take that away. Okay. That's very helpful. Ecliptic poles. This, like the celestial poles, are the center of our rotational moment. This south ecliptic pole, you're going to see highlighted on the ecliptic grid. They're like the center of our orbital motion, or the sun's path through the sky. Zenith and nadir, huge, right? So you will see up above our heads Z. It's hard to tell that's up above our heads when I zoom all the way out like this, okay? I can see it when I bring in the azimuthal grid, kind of the dome of my local heavenly experience, right? But if I don't want to have all of that grid in, it's helpful to see Z, which is the zenith above my head, and Z prime, which is the nadir down beneath my feet, in a place I will never see, below the ground, okay? All right, almost through with our list. The galactic poles and the supergalactic poles, I think you get it, right? Like every one of these grids is going to have poles and an equator. So galactic grid or galactic equator and galactic poles, right? I would probably, I mean, it should change all of these colors accordingly. I'm actually going to do this one right now. And I don't know, usually I use blues like that for equatorial stuff, so I'm going to work on that later. Quadrature circle. I don't know. What are you? Let's see. It moves through time. It moves with time, I should say. It's going through, like, I don't know, 10 tropical Taurus. I have no idea what that quadrature circle is. I'm intrigued, but I have no idea what that is. So it's not for me to say. We're gonna have to go to the World Wide Web and learn that out. The anti-solar point. Oh, that's interesting. That will also help in my teaching. Okay, so the sun is currently at 3 tropical Pisces, although I'm no longer on today. I'm pretty close. It's like 5 or 6 tropical Pisces. So I assume an anti-solar point here is drawn in at 4 or 5. Tropical Virgo, absolutely, because Regulus in our day and age, and this happened in 2012, is now at the 1st degree of Tropical Virgo. That anti-solar point will actually be very helpful because it's a place that will separate the morning stars from the evening stars and help us see like what stars are currently aligned to acronychal rise, rising at sunset. Also new in my Stellarium experience, super cool. Earth Umbra. That's the shadow of Earth. Let me bring in the atmosphere here. I'm gonna look west at sunrise. Whoa, too fast. The ground beneath our feet. I mean, let me turn it on and off and see if that's where it changes. I don't know where Earth, Umbra, and Penumbra, which have to do with the shadow of our planet, are gonna come in. Invariable plane of the solar system. So that's an interesting one, right? So I don't know if that's like it shifts from the ecliptic because of like earthly motions like precession or nuation, or if it's just talking about like distances the planets get from the ecliptic. I'm guessing it's one or the other. By the way, you can hear how my house is coming to life right now. So I'm just gonna finish this sub menu, this markings menu, and then we'll do landscape and sky lore and a sky culture in another video, okay? So we finally see center of FOV, circular FOV, rectangular FOV. I just highlighted them all. That's all of this, okay? So the center of my field of view, let's say I center on Antares here, space bar. Okay, now you can see Antares is right in that mix, right? So obviously if I turn the circular and rectangular off, we just get the hash marks. That's the center. Let me turn that on and off. Okay. Circle opens that up, and clearly I can increase the radius of that circle here. It looks like it's a degree measurement of diameter is my guess. And then I could replace that with rectangular, and clearly I'm able to change the dimensions of the rectangle as well. Oh, and look at that. I can rotate that rectangle from the horizontal of my field of view. That seems maybe to be most useful for telescope folk. I'm trying to figure out how I would utilize that in my astrology. Okay, but our main things today were make the Stellarium screen look like an astrology chart. And things that we needed to do that is to bring in the ecliptic, bring in the meridian, bring in the horizon, so for when the ground is not beneath our feet. Trying to go to this chart that I had on Astro Gold over there, and now we have our chart wheel. Again, it looks a little bit different because this is not only beneath the ground, it's also behind us if we're facing the ecliptic in the southern hemisphere, which is south. If I'm facing due south, I'm actually facing this meridian, MC. If I turn my shoulders to the ascendant descendant directions, which change during the course of the day or rudder back and forth against the cardinal directions, then my heart is facing the highest part of the ecliptic curve, which is always square to the ascendant descendant axis. So again, because that changes every day, it's only here in like this moment, one other moment, which is Antiscia this degree or Antiscia. That's a tale for another time. I'm going to keep my focus on the south. I'm going to save that view. I like to have the ground beneath my feet. Excuse me. So I'm going to end here by going to the configuration menu, save view, save settings. All right, see you next time in video number 13, where we will finish with the sky and viewing menu, go through these different landscape options. I will also show you how you can add landscapes, and then go through the sky cultures. And yeah, I am seeing something that makes my heart frown a little bit. We'll get back to that next time. Until then, friends, I will see you in space.